Hello everyone and welcome to today's case study on data centers and the climate. In preparing to deliver this presentation, it occurred to me that the impact of our day-to-day minute-to-minute internet activity on the climate is not at all well understood. Indeed, we are so dependent on data centers to provide us with access to the virtual world, from Netflix to WhatsApp, Spotify to Apple Watches, that we probably wish we didn't have to countenance the fact that the digital world has any significant negative impact on our warming planet. Unfortunately, it's a reality we cannot afford to ignore. So what exactly are data centers? Well, to paraphrase Mary Boran, it can often seem like everything we do in the virtual world sits in the cloud. But the reality is all our data is being processed and transmitted in and out of physical buildings. That's the reality. Data centers are a physical space located within a building which houses computer systems, telecommunications, and storage systems, an example of which is shown here on the right. That's all the cloud really is, a collection of data centers. These data centers are comprised of backup components and a power supply infrastructure, as well as environmental controls such as air conditioning and fire suppression. They vary in size and scope, with industrial scale data centers consuming as much electricity as a small town. Given this large energy demand, you may begin to see why this is increasingly becoming a problem with regard to our climate. Hence, we can begin to answer the question, how are they impacting the climate? In 2016, the world's data centers used more than the entirety of the UK's total electricity consumption, at 416.2 terawatt hours, far more than the UK's 300 terawatt hours. This works out at 3% of the global electricity supply and accounts for around 2% of total greenhouse gas emissions in that same year. In sum, data centers have roughly the same carbon footprint as the aviation industry. As the number of internet users increase around the world, especially as the developing world starts logging on, we can expect a massive increase in the number of servers and data centers to meet this accelerating demand, as depicted in this graph. Today's forecasts project that by 2040, storing, transmitting, and receiving digital data via data centers will account for 14% of the world's emissions. That's roughly equivalent to the United States today, a massive increase over 20 years of 12%. Indeed, every 4 years we are seeing the amount of energy used by data centers double. This means the carbon footprints of data centers are the fastest growing emitters within the IT sector and certainly one of the fastest and most significant in the world right now. So how exactly are they consuming so much energy? Well, it's quite simple really. Data centers need a 24/7 energy source, which too often remains fossil fuel based, to power and run the servers, storage and computer systems which provide us with cat videos on YouTube and allow us to send messages on WhatsApp. 70% of the energy used by data centers serve this purpose. As well as fulfilling this primary purpose, 25% is dedicated to a data center's cooling system. Why? Well, because like your home computer, data centers produce a lot of excess heat and need a fan to cool them down. Since energy is dissipated at heat within a small area, IT equipment is incredibly sensitive to high temperatures. Hence, computer systems must be continually cooled. Despite these efforts, standard air-based cooling systems remain fairly inefficient, so tons of waste heat is produced, something I'll return to in a moment. So, what is the scale of the problem? Well, last year, during the height of lockdown, Netflix's Tiger King recorded 5 billion minutes of streaming. This translates into an estimated 33.3 thousand tons of carbon dioxide of data center emissions. The 2017 hit song Despacito, at 5 billion plays on its YouTube music video, has, over its entire lifetime, consumed as much electricity as Chad, Guyana-Bissau, Somalia, Sierra Leone, and the Central African Republic in a single year combined. That's over 250,000 tons of carbon dioxide according to the University of East London. You may have also heard the claim that each Google search generated as much CO2 as boiling half the water for a cup of coffee. So about 7 grams of CO2. In reality, the actual figure is much lower at 0.2 grams, but think of how many Google searches there are every hour. It's going to very rapidly add up. In comparison, a cat video on YouTube produced considerably more CO2 at 1 gram of CO2 for every 10 minutes of viewing, while using Gmail for a year produced about 1.2 kilograms of CO2 per user. Not only are spam emails a personal nuisance, they're also a verifiable contributor to our warming planet at around 0.3 grams of CO2 per email. Standard emails are larger at 4 grams, while emails with hefty attachments can contribute as much as 50 grams. If you zoom out, Lancaster University estimates a typical business user creates 135 kilograms of CO2 equivalents from sending emails every year. That's equivalent to driving 200 miles in a family car. It's even the case that if we eliminated niceties in emails, like thank you, we could collectively save in the UK 16,433 tonnes of carbon a year, or the equivalent of taking 3,334 diesel cars off the road. The exact same can be said for unwanted newsletters to your inbox. The average user receives 2,850 unwanted emails every year from subscriptions. They're responsible for 28.5 kilograms of CO2 equivalent. Online videos like Netflix, Amazon Prime, YouTube, and so on, they account for the biggest chunk of the world's internet traffic, or 60% overall, generating 300 million tonnes of carbon dioxide a year, roughly 1% of global emissions. This includes not only the streaming of data, but also the powering of TVs and monitors as well. Internet pornography alone accounts for a third of video streaming traffic and generates as much carbon dioxide as Belgium does in a year. Finally, we have a new challenge on the horizon: cryptocurrencies, which demand vast amounts of computing power to operate fiscal algorithms and validate transactions. Bitcoin alone is responsible for around 22 million tonnes of carbon dioxide emissions every year, generating the carbon footprint equivalent of Jordan, actually greater, and that's only set to grow. So that's the scale of the problem. What are the potential solutions? Well, there are 3 obvious solutions. Number 1, ensuring data centres are supplied with a fossil fuel-free electricity grid. Number 2, continuing to invest in R&D, which makes the IT equipment used in data centres less energy intensive and more efficient overall. And number 3, we as users can reduce our usage and store more of our data on personal hard drives rather than storing it on public clouds. However, one of the best and most simple ways we can reduce the carbon footprints of these vital data centres is to build data centres in colder climates. As mentioned prior, 25% of energy consumed by data centres goes towards cooling servers. The fact is, most cooling systems used today are incredibly inefficient and are using unnecessary amounts of energy. By simply moving data centres to nations with colder climates, far less energy is needed to keep servers cooled, thus less energy is dedicated towards mechanical refrigeration systems, the likes of which you see in warmer climates. For this reason, Norway has attracted a lot of attention from Microsoft and Facebook. Indeed, Norway has forecast that data centres' electricity consumption will grow from 0.8 terawatt hours today to between 3 and 11 terawatt hours by 2040 as these large corporations move data centres to the country. It should also be said Microsoft have done something quite similar with data centres off Scotland's west coast with submerged data centres, which can deliver processing power to nearby cities. So this proposition can work not only in Norwegian mountains, but also in the depths of Scottish seas. It's also the case that the remaining excess heat which is produced, aka waste heat, can be captured and utilised in a myriad of different ways within colder climates. Together, this maximises the overall efficiency of the data centre by deploying an efficient cooling system, thus reducing energy consumption, in tandem with improving the potential for utilising the waste heat produced. In reality, this means firstly switching from inefficient air-based cooling systems which produce lower waste heat temperatures with either liquid-based or two-phase cooling systems, both of which are more energy efficient and deliver waste heat of around 60 to 80 degrees Celsius. In other words, heat which can be used directly for many other purposes. Among the many ways we can utilise waste heat include district heating with the aid of a heat pump, as shown on the left, conversion to electrical power to supply to the grid, as shown on the right, Also, rather counterintuitively, it can be used to produce cooling by way of what is known as sorption cooling, biomass processing as well, and even food production. Now, data centers can of course be used in both an urban and rural environment. In urban areas, we can see how data centers could provide local areas with district heating, as heat pump technology can lift the waste heat to the required temperature level. Indeed, this is already being put into use in Oslo, Norway. In rural areas, they have the advantage of plenty space where they can better exploit renewable electricity opportunities to power their respective data centers and use the natural environment to their own advantage, locating data centers in cooler valleys, for instance, albeit with less potential for waste heat as rural areas lack the proximity necessary to fully optimize system efficiency. What governments and communities need to be wise to is ensuring there is a co-location of relevant industry and or residences which can benefit from the use of waste heat, leading to substantial energy and emissions savings. Finally, it's also worth noting that it's important to look upon data centers as something closer to energy hubs in that sense. By integrating electrical and thermal energy demands, data centers can adapt to shifting demands from local communities depending on seasonal changes. For instance, in the winter, a shift to heat can be made to account for increased demand in the district heating system. Meanwhile, in summer months, a higher fraction of electricity is delivered to cool systems. So, to briefly conclude, we are an increasingly data-driven society. That isn't going to change. As a global community, we're going to be consuming more and more data in coming decades as developing nations log on. This poses a huge environmental challenge we need to fix. However, data centers can be made more efficient by taking a few simple steps, like moving them to colder climates, investing in more efficient data systems, regulating our own behaviour so as to be less wasteful when it comes to accessing data, and utilising excess waste heat for other purposes. None of these are impossible, but the scale of the challenge is nonetheless daunting. Thank you very much.